And I would like to take this opportunity to welcome some local engineering students that I have in this class. My name is Olenjolai, I am a Tanzanian, and I'm very happy to have you today. And I want to tell you that in advance I have a good news that I know will help you in your journey in your journey of learning engineering, either in ordinary diploma level or in advanced diploma level or in undergraduate level. So today the main topic that we are going to learn, the subject name is called the basics of electronics engineering, as just I have written there on the blackboard. And the topic we are going to focus today is called electronic measuring and the testing instruments. So with the local or online student, I would like to tell you that make sure that you are along the process of learning, because sometimes I might teach you some new skills whenever that you ask a question. So don't hesitate yourself to ask your questions, be interactive. I believe that you love electronics. In case that you don't love it, if you join me in this workshop, which actually that we can call to workshop number 1 or workshop 0, because in digital electronics we used to count from 0. 0 is a valuable number. So if that's the case, and this is a practical program, we are going to discuss, or we are going to learn in 3 main parts. We are going to cover the theory, then we'll go for the simulation, and finally we'll go for the hardware implementation. So let me appreciate the students who have joined with me in this workshop or in this practical class. How are you, students? How are you again? Are you? Okay, so you hear their appreciations and acknowledgement that they are ready to learn. So I believe even you who is invisible in our eyes, but you are back of your computer or your mobile phones or your iPad, I think that you are ready. So let us go into today's business. So this is the workshop 0. In this workshop 0, or let me just write it here. This is the abbreviations of the word workshop 0. So after we are going to discuss about introductions of one measuring and testing instrument, which is called the digital multimeter. Students say digital multimeter. Again, say digital multimeter. So digital multimeter. So today we are going to discuss about 2 categories of the digital multimeter in the context of how to use them. So you say that in electronics engineering, there are 2 categories. There are 2 categories of digital multimeter. So you have 2 categories of digital multimeter. And these 2 categories of digital multimeter, namely, the first one, we have automatic. Say automatic digital multimeter. So we have automatic, or in short we call it automatic range digital multimeter. And the second category is called the manual range digital multimeter. So these are the very important 2 important categories that you have in electronics. So class say automatic or out range digital multimeter. Say automatic or auto range digital multimeter. I said say automatic or auto range digital multimeter. So auto, it's abbreviations of the word automatic. So whenever you find the word auto, whether in electronics or in mechanical, that's the abbreviations of what? Remember the automatic system, listen. When I'm explaining the concept, you have to stop writing. You have to listen and watch. So when you say automatic to a particular system is automatic, it means that there is a minimum human intervention. That's the meaning of automatic system. If you say that I want to design automatic maybe fire detector system, so it means that in that system there is a minimum human intervention. That's the meaning of who. There is a high extent of the human intervention. That system is not digital. It might be either manual and the auto. Because we have some systems which are pure automatic system. Ruben is writing. We have some systems which are pure automatic. We have some systems which are pure manual. We have some systems which are mixed, the auto and the manual. But the simple concept that you should have at the beginner in electronics, whenever we say auto system, there is a minimum human intervention. What does it mean? For example, in order to establish the system, maybe the human being is just to turn on the system, then the human. Every functionality or activity will be performed by the system itself. Or sometimes just the human being is actually at maybe turning on and then doing some, and from there the human being will not intervene or will not interact with that system maybe for 2 days or 3 days. So the system has intelligence to define different situations. Are we together? So when you say that the system is manual, it may find some parts which are not manual, but there is a high human intervention. So when it comes for the concept, that is the general meanings of automatic and the manual in the context of engineering. When it comes for the digital multimeter, when you say that this is auto range, say auto range. So it means that the range of that digital multimeter will have minimum human intervention, minimum technician intervention, minimum engineer intervention. Are we together? When you say manual range digital multimeter, there is a high human intervention. And why should we teach you categories of digital multimeter? Because these are what we can find in the industry of digital multimeter. A digital multimeter can be either auto range digital multimeter or manual range digital multimeter. Are we together? Are we together? So let us narrow the concepts or go in depth about automatic or auto range digital multimeter. Digital multimeter. Auto range digital multimeter. So you say that the question, this is question number 1. What is auto range digital multimeter? What is auto range digital multimeter? So simply we say that if the digital, so this the digital is a digital multimeter. This is the digital multimeter in which the human being or the user means the technician or engineer has minimum intervention. When you say that intervention on setting the range of the particular instrument. So that's the meanings of auto range digital multimeter. So the user has minimum intervention. It means that the user has only the responsibility to choose what? Just the instrument. So another key point, we say that, not before, all digital multimeters have rotary switch to provide the choice of the particular instrument. So say all digital multimeters have rotary switch to provide the choice of the particular instrument. So the rotary switch is used to select. So the rotary switch, class A rotary switch. Say rotary switch. So rotary switch is used to select the instrument, selecting either the measuring or testing instrument, selected either the measuring or testing instrument built in the digital multimeter. So the rotary switch, it's the one that used to select. The rotary switch is used to select either the measuring or testing instrument built in the digital multimeter, because you may not choose the instrument, whether the measuring or testing instrument, which is not built in within that digital multimeter. So this is the first function of the rotary switch. Number two, the rotary switch is used to select the particular measuring scale. The particular measuring scale built in manual digital multimeter. I will demonstrate to you, so you should not worry. You understand what the meaning of the rotary switch. So it's better to introduce to you the concepts of rotary switch, because it's the one that's the point where you see the difference. This is digital multimeter, and also this one is digital multimeter. Listen. This is digital multimeter, and this is also digital multimeter. When we talk about rotary switch, we mean about this one. So this is the rotary switch. It means that, why do we call rotary? Because rotary first comes from the word rotation, right? So it means that this switch is rotating. Okay? So it's rotating from off, then rotating in this way, out to another point where they're off. So this is auto digital multimeter. This one, is what? Manual. So the manual digital multimeter also has what? A rotary switch. So this is what we call the rotary. We have different electronics and electromechanical switches. So this is our digital or our rotary switch. Are we together? Yes. So we say that for the digital multimeter, the function of rotary switch is just to choose the type of measuring or testing instrument. That's right. But for the manual digital, the rotary switch has two functions. Hey, listen. The rotary switch has two. Number one, the function of rotary switch is to choose a particular instrument. For instance, to choose DC voltmeter. That's the first function. But the second function, this rotary switch is used to choose a particular scale, or a particular scale that according to the magnitude of the electric signal that you are going to measure. Why? Because in manual, we have also extended scale of the particular measuring instrument. So the function of this rotary switch for the manual switch is just to choose the instrument, whether it is digital, whether it is DC voltmeter, you have to use this one to choose, or it's ohmmeter, whether it is capacitance meter, whether it is frequency meter. So you have to use this rotary switch to choose that particular instrument, right? Right? But again, you'll find that for the manual, there is an extended scale. For example, you can find that 200 ohm, 202 mega ohm, and maybe 20 mega ohm, or maybe 40 mega ohm. So I mean that's the extended scale. So you'll be using the rotary switch also to choose a particular scale according to the magnitude of the physical quantity that you are going to measure. Are we together? So we'll discuss in detail, because today our main focus is to understand how to use manual digital multimeter and the auto range digital multimeter in your, or in to do, it means that in measuring, in measurements of electronic system. Are we together? Okay. So after I define the word auto range, then I say, okay, it's fine, because the simple way for you to distinguish the auto range digital multimeter from manual range digital multimeter is just on the rotary switch. Okay? Are we together? So this is the second function. So this second function, we just find it only in the manual. Manual, we call it manual range. So I forgot the word, what? Range. Digital multimeter. Are we together? Eh? So then this is another point that you have to know. We say that every rotary switch has what? So every rotary switch has a pointer. Say pointer. Say pointer. Say pointer. To point the particular, particular instrument or particular scale. Particular instrument or particular scale in case of the measuring instrument. So every rotary switch has a pointer. Say pointer. To point to a particular instrument. So if that's the case, let me draw the structure of the rotary switch. So here it's a rotary switch, and here it's what we call it a pointer. So this is the rotary switch. You can find that here you have the word off, and also here we have another word which is off. So the pointer is this one. Remember, this is not the pointer, this is the base. Listen. So this is the pointer. So this is the pointer. To point to a particular scale. Are we together? So you have to be careful, because sometimes it can be a mistake. You might rotate this pointer to here, and then that this is the one of the instrument, but there's another instrument. So sometimes you might think that I have set a digital multimeter into DC voltmeter, while frankly speaking, you have set it into DC ammeter. Are we together? Are we together? So whenever whenever you've been given any digital multimeter, identify where the pointer is. Okay? And be careful, because sometimes in interview you might do some common mistakes, that you rotate and you might think that the pointer is this one. Or you might think that it's a two-directional pointer, while it's one-directional pointer. This is not bidirectional. It's mono-directional. Are we together? It's actually rotating clockwise and anti-clockwise. But in case of the pointy, it's only one side that's pointing the particular instrument. Are we together? Are we together? Do you have any question at that point? Do you have any question? Okay, so this is another point. We say that another concept that you have to remember as technician or electronics engineer is this one. If this is the pointer, and we've discussed about the rotary switch, that is good. Now we can keep focus. So another concept that you have to know, we say that the auto range digital multimeter, the auto range digital multimeter can measure any magnitude of electrical and the magnitude of electrical signal and a signal within the minimum and the maximum limit of the particular measuring instrument. So say the auto range digital multimeter, stop writing. The auto range digital multimeter can measure any magnitude of the electrical signal within the minimum and maximum limit of the particular measuring instrument. What does it mean? Let me give you an example. Example, Mastec MY68 can measure DC signal within 400 millivolt and the 1000 volt by just a single choice of the DC voltmeter. So what does that sentence mean? Listen, stop writing. I say, Mastec MY68 is this digital multimeter. Its name is Mastec MY68. If you want to use the DC voltmeter, when the rotary switch is off, you just need to rotate it 2 steps. So this is the DC what? Voltmeter. Just need to rotate the rotary switch into, or you want to set, or you have to set the point of the rotary switch at what? At the DC voltmeter. DC what? DC what? Voltmeter. Once you set the pointer to the DC voltmeter, then this digital multimeter itself will change or will do the measurements of the DC signal within 400 millivolt to 1000 millivolt without any human intervention to the DC voltmeter. Let me repeat. I say, let me explain by using drawing. because it will be easier for you to understand what the meaning of this concept. Here, it's a rotary switch and the skull of the mastic. So this is mastic MY68. Here it's off. Here we have AC voltmeter, and here we have DC voltmeter. This is workshop what? So this is workshop 1. Workshop 1. Okay? So here it's a pointer. So in order for you to use DC voltmeter, you just need to set the pointer into DC voltmeter. Then you are done. So you rotate the rotary switch from off to this DC voltmeter, you are done. So it means that you can measure DC voltmeter from 400 millivolts to 100 volts without any adjustment of the rotary switch. Are we together? So the instrument itself, it means that change from millivolt or millivoltmeter into voltmeter automatically. Are we together? If you say that this is a manual range, it means that you should know the magnitude of the electrical quantity that you are going to measure. And then you have to choose the instrument, then you have to choose a particular scale according to the magnitude of the signal that you are going to measure. So this is auto range digital multimeter. Why? Because the reasons that make it to be auto range, you just need to choose the measuring instrument, that's all. Are we together? So it means that for that measuring instrument to measure the electrical quantity between the minimum value and maximum value, the instrument itself, it adjusts, it means it adjusts, it readjusts. There is no any human intervention. Are we together? Class, are we together? So just to keep in touch, when I will teach you about manual, you will understand the difference between them. And then you'll find that the manual range digital multimeter has a lot of human intervention. Are we together? Okay. Okay, so another thing, let us, we say that this is one of the examples. So you say that, let me give you some examples of what. So you say that in electronics, and let's say telecom engineering, there are different types or different types of working, types of auto range digital multimeter. Range digital multimeter. So let me give you some examples. The first example, we have Mastec MY68. The second example, we have also UTE 61, UTE 61 E plus digital multimeter. Also, we have another example, WIGAO digital multimeter. WIGAO, or I think that this one is called the UA92 43 E WIGAO. Then number 4, first example, we have also mass tech, MS 8229. 8229. Digital multimeter. So these are the simple examples. So here it's Mastec MY68, and then this one it's UT. This one it's UT61E plus digital multimeter. It's out of range. Also, we have UA9233E. So we go, okay? Another example of digital multimeter, of outer range digital multimeter. Then you have MS8229 master digital multimeter. So we are not learning the concepts of digital multimeter in such a way that maybe you will be capable to make a digital multimeter. The theme of this program is actually we have to teach you what can you do with digital multimeter and how can you do it. Okay? What can you do with digital multimeter and how can you do it? So now let us take a simple, because the scale also is very important. Let us take this here, we say that rotary switch, and the scale of Mastec MY68 auto range digital multimeter. So this rotary switch is very important for you. Here's my rotary switch. How about yours? This is mine. So in this rotary switch, we have a point that we call T off. And then we have a quantity V dash. This is what? AC voltimeter. Then this one it is DC what? DC what? Voltimeter. Then this is what? A ohmmeter. And then this is what the names of this instrument? Continuity tester. Then you have slash. Then you have another symbol, another instrument. What are the names of this instrument? Now the tester. Then the other ones we have capital A, C. What are the names of this instrument? Capacitance meter. Then another instrument is what? Frequency what? Frequency meter. Then you have another instrument which is HFE, which are abbreviations of what? Hybrid forward emitter. It means that the transistor what? Tester. For those students who have dodged the previous, they are just smiling. So then we have this one, this the symbol. We have the symbol for DC or non-contact ammeter. Then we have another instrument. Okay, stop writing, stop drawing. Starting from Jacqueline to Brighton. This is the rotary switch of 40 of Mastec MY68 digital. Eh? So this is what we call T point, and the pointer is here. So this is called T point. So this is pointer, but this we call it pointer head, or we call it just like a part of an arrow, or indicator, pointer indicator. So simply call it pointer head. But this one, we just call it pointer. Why do we call it pointer? Because it will point, it will make a right choice of the particular measuring or testament. Are we together, class? So with this one, look, listen. This is all the measuring and testing instrument built in within the Mastec MY68. Are we together? Are we together? So why do we call it auto range? First of all, you will never see numbers in auto range digital multimeter. Do you see any number? Eh? What do we see? We just see symbols of measuring and testing instruments. This is the symbol for measuring instrument that's called the AC voltimeter. Why do we call it the symbol? Because we have two symbols together. So this is not as the AC unit of voltage, it's a voltimeter. It's AC voltimeter. Because this one indicates the instrument, but this one indicates the nature of the signal. Are we together? Are we together? And remember that when we say that alternating signal, we don't mean that it's always what? It's always sinusoidal. It can be a square wave. So when you find a digital multimeter which shows also the nature of the waveform, it means that this AC voltimeter can only measure alternating voltage. This digital AC voltimeter can only measure alternating voltage, which the nature of its waveform is sinusoidal. If the nature of this waveform is square wave, then this measuring instrument will never be able to measure it. Are we together? Because square wave always have a positive pass and negative pass. It has a negative half cycle and positive half cycle. Are we together? So this is AC voltimeter. This one is what? DC voltimeter. Why? because V stands for the voltage or for the voltmeter. But these two signals, this is straight line, stand at the what nature of the DC signal. DC signal, graphically, for example, sinusoidal signal, the nature of it is this one. The DC signal, the nature of the DC signal is always a straight line. That's the meaning of this symbol. Are we together? Are we together? Yes. Then this one, it's a symbol for what? It's a unity of resistance, which we call it ohm. So represent what? Ohmmeter. But ohmmeter between the minimum limit and maximum what? Limit. Are we together? So you just saw, or you just see the ohmmeter here. You don't see any number. So if you don't see any number, that is the outer range. Jacqueline, you are chatting. Then again here, we have the combinations of 40 of the two testing instruments. Simply, at this point, we call it continuity test. Continuity and the diode testers. Continuity and diode testers. The word testers should have S because it is plural. It's more than one testing instrument there. So this is the continuity tester. And this is diode tester. But remember that there is one which is default. And the default test instrument here, it is diode tester. So in order for you to switch your digital multimeter into continuity tester, you need another button, so we call it selector button. So when you press the selector button, then you twist your digital multimeter, you change from the diode tester into continuity tester. Are we together? So these are the testing instruments. Hello, Isa. Then we have another instrument which is called capacitance. For this digital multimeter, the symbol which has been used is cap. But for term of them, they can just use F, representing farad, or microfarad, or nanofarad. So you should not claim, you have to understand the concept behind the electrical science and the concept behind the electrical quantities. So you have to remember the SI unit of the physical quantity or the symbols for the quantity itself. Are we together? Are we together? Because this is not a symbol of resistance. This is the symbol of SI unit of resistance. Then we have Hayes. Hayes is abbreviations of 40 hertz. Right? So this represents what? Frequency meter. Then you have what? Hybrid forward what? Ammeter. So this is diode tester. So beside it, we'll also see 80 holes indicating that this is emitter, then base, collector, emitter. Emitter, base, collector, emitter. Then here you'll find that you have the first hole, second hole, third hole, first hole. Also you have on this side, and this side, and this side. So I mean these holes will work together. When you set your digital multimeter into a hybrid forward emitter, you can use these holes to identify, first of all, the name or to name the terminals of NPN, because this one, on this side we have NPN, and on this side we have PNP transistor. So these holes and transistor tester, first of all, will identify whether the transistor is NPN or PNP. And we'll discuss that in the topic of transistor, the special bipolar junction transistor. But again, this transistor tester can help you to identify which terminal is base, which terminal is collector, and which terminal is emitter. Are we together? Again, the transistor tester can help you to measure the DC current gain, which we call it for the common emitter, we call it beta. Beta is equal to collector current over base current. Are we together? So this also is the testing instrument. Then we come for this case, this is the part for the ammeter. But this one we call it what? DC and the AC micro ammeter. Why DC and the AC micro ammeter? This is the symbol for the DC waveform, or this the waveform, DC waveform, and this is the nature of the AC waveform. So again, in order for you to switch, the default is DC microammeter. So when you rotate the rotary switch up this point, then what will happen? So the default is DC microammeter. In order to change into a C microammeter, you have to press the selector button. Are we together? The same process for this one, for milliammeter, and also for the ammeter. So how many measuring instruments do we have there? Class, I ask you, how many measuring instruments do we have there? Eh? 10 and 14. And how many testing instruments do you have? You are still confusing measuring and testing instruments. You said you have 14 measuring instruments. How many testing instruments do you have? I didn't ask you combination of measuring and testing. I asked the measuring instrument, how many are they? 8. So you change the answer now, it's 8. Before it was 14. And testing instrument? Huh? Huh?